Hello everyone and welcome to today's webinar on the importance of making IPR part of your cellular module supplier selection process. Next slide please, Craig. Today we will be discussing IPR risks to your IoT business, the background of SEP licensing, real-world experiences from our guest speakers, and what are the right questions to ask on the topic of IPR. As always, this webinar will be recorded and sent to you automatically. The presentation is available in the handout section of the control panel, and please feel free to ask any questions in the control panel seen to your right. Next slide, please. Our speakers today are Craig Miller, Senior Director of Product Strategy at u-blox, Kent Baker, Head of Intellectual Property at u-blox, and our guest speakers, Thomas Lobert, Managing Director at SMIG, and Sebastian Heideprüm, Head of Wireless Technologies at SICK AG. And here are some disclaimers just to keep in mind for today's presentation. And I shall hand you over to Craig. Thank you very much.
Thank you, and thank you all for joining us today. We're going to start out by talking about the threats and kind of the risks related to intellectual property rights in cellular IoT business. So cellular technology comes with a pretty unique set of what we might call rules of engagement, where intellectual property rights are concerned. And these rules are a little different from those you might encounter in other technology areas. And they relate to something called standard essential patents, which I'll define shortly. For now, you just need to know that if you don't recognize and play by these rules, there is a lot of risk to your business. So just keep that in mind. And these risks include things like a disruption to your business, the ability to ship your product or offer your service, big unplanned drains to your human resources, significant financial costs, and even damage to your good reputation. So these risks are real and damaging. And they're growing. So there are inventors out there who are really just simply pursuing fair value recovery for their patents on their own R&D investments, but there are also others, mostly what we'd call non-practicing entities. Sometimes these are called trolls, and they build business models solely to make, frankly, outsized profits on patents they had no role in creating. Regardless of the motives and the drivers, there's clearly a steady increase in the amount of litigation being used by these players to collect royalties on these patents. Now, there are ways to mitigate these risks, and one of which is choosing carefully who your suppliers are for the cellular technology. So just kind of a few data points here about how aggressive patent holders are becoming in their efforts to get paid. So in the first quarter of 2021, this is some data where we saw more than a 43% year-over-year increase in the number of defendants named in patent litigations. And this is on top of similar annual growth rates from prior years. So the patent owners do this because it's their right to protect their innovations and get paid for their inventions. And they do it because it's also profitable. So now, this is not all strictly cellular IPR here we're talking about, but for certain, we see the same kind of magnitude of growth in cellular litigation, including in IoT. It's not just the mobile phone industry that's seeing litigation here, and we'll see this on the next slide. So if you are in the IoT device or service business, those risks, the disruptions and financial costs that I mentioned on the previous slide are increasingly likely to happen or to impact you. So specifically looking at cellular IoT, this is an example of some recent litigation, current litigation, frankly. And we've anonymized the defendants here, but trust me, the defendants named in these suits are well-known cellular module vendors and some of their biggest customers that have been named as defendants by some big players who own substantial standard essential patents. Now, what's important here is not only did the module maker get sued, but the end customer got sued. So none of these parties have a license to use these these standard essential patents that are subject of these cases. And these device makers are large, reputable firms with, strong businesses in their respective markets, and they were all exposed to these risks that I talked about on that first slide, the risk to their financials and their resource consumption and their reputation. And this is just a couple of examples. There are numerous other examples of patent owners who took similar actions in the last few years. And again, the point here really is that litigation is happening. It's on the increase, even in our IoT world. So if you're in this space, it's increasingly probable that you'll be, maybe potentially exposed to these situations. So I believe we have a poll now.
Yes, to start things off, let's go to our first poll. So please select one of the following to the question, how many employees does your company have? Less than 100, 100 to 500, 500 to 1,000, or more than 1,000? See a lot of answers coming in right now, so we'll give it another minute or a few more seconds. I think we can close the poll and go to the next one. So it's an interesting split here. A lot of people in smaller companies with under 100 employees, and then also quite a few with more than 1,000. Let's move to the next poll. Okay, so this question is, what is your level of knowledge about SEPs? Please select one of the following: none, limited knowledge, knowledgeable, or expert. All right, I think we can close this poll. Excellent. I think we were kind of expecting something along those lines for this webinar. More than half of you with limited knowledge, and then some with none, and then 15% that also consider themselves knowledgeable. So hopefully this will be useful today. Let's move on with the webinar.
Okay, thanks. So I didn't intend to scare you, but you should have some trepidation about the risks surrounding cellular IPR from the introduction section there. Let's actually go back now and spend a few minutes kind of explaining, some of the terminology and some of the basics behind all of this. So what is IPR? So if you're attending this webinar, you probably have some general idea, even if you're not an attorney, a patent lawyer, what have you. You probably have a basic understanding of intellectual property and some of the rights that relate to it. So you've at least heard of it if you're attending this webinar. So in the US and frankly most of the world, intellectual property can be protected by certain legal instruments, and one of the most important of these is the patent. And basically, oversimplifying, if you invent something, you have a right to patent it, which gives you the further right to prevent others from making it or selling it, anything that contains that innovation or that invention. And it also gives you the right to license it to others for a fee so that they can make or sell that innovation in their products or services. So this is kind of the basics, the essence of IPR. And in our industry and in most industries, it's common for a fee or a royalty to be assigned or charged for such a license. We're going to talk more about that later, how that kind of works mechanically in our industry. So, and in this section, in this webinar, we want to talk about a particular special category of patent, something called standard essential patent. And the fact is, in cellular, if you want to build a device that includes cellular technology from a 3GPP standard, you will infringe perhaps hundreds or maybe even thousands of patents. It turns out that ETSI, which is the organization that oversees the 3GPP standards bodies in defining these standards, 3GPP incorporates patented inventions into the standards. The contributors offer their inventions to the standard, and those can get incorporated into the specs. So, and when these patents can't be worked around or engineered around, they're called standard essential patents, or SEP or SEPs. So you'll hear us refer to SEP or SEP in other parts of this presentation. So Just as an example, in LTE, for instance, LTE requires the use of certain technologies, things like you've heard of probably like MIMO, OFDMA, turbo codes, hundreds of others patents. And all of these were invented by contributors to the standard and patented by those contributors. But they were offered to the standard under some special conditions that I'll talk about on the next slide. And many of these patents turn out to be standard essential. They can't be avoided. You have to use that invention if you want to support the standard in your product. So they are necessarily then infringed in every LTE product. That is a standard essential patent. So how big is this situation? So just looking at, to give you an idea of the scope here. So this is a chart from some Etsy data that indicates the claimed ownership of more than 5,700 declared standard essential patents in the LTE standard. So 5,700 plus patents and literally hundreds of inventors that contributed. So now, not all patents are infringed in every device. Some of these patents cover things that might be in the core network or the radio access network or in some special version of the standard. And so not every device infringes on every inventor and every patent. So, and it's also worth noting that some of what are declared by these inventors as standard essential may not really be standard essential. Sometimes courts get to decide this. We're not going to get into kind of the debate here about what's essential and not essential. And we're also not going to sort of get into the nuances around the relative importance of different patents or how many patents are owned by a particular inventor or contributor. So the real point here is there are lots of patents that are standard essential from a lot of owners, and this can't be avoided. You will infringe many of the patents in this pile here. So, and really the essence, again, because of IPR, the way IPR works is these owners have a legal right to be paid. And that's complicated, right? So the challenge is how do you, as an implementer of a cellular device, kind of navigate all this in a way that helps you avoid some of that messy risk I talked about earlier. So I mentioned earlier that the contributors have certain terms or conditions they have to agree to when they submit a patented idea. And these terms are summarized by this term here called FRAN, which is fair, reasonable, and non-discriminatory. The inventors of standard essential patents agree to offer their invention to the standard under something called FRAN terms. Now, unfortunately, Etsy did not define what FRAN is, what it really exactly means. So there's some general guidelines, but there are no set terms or conditions for using SEPs, no guidance on how to value a particular SEP or family of SEPs. There's no dollar amount that's assigned to an SEP and so on and so forth. Not everyone then will end up paying the same for a given SEP or SEP group. So FRAN doesn't mean equal, doesn't mean pay the same amount. The financials and those terms and conditions are pretty much left to the players in the industry to agree on. And sometimes they disagree on that, and sometimes that gets into the courts. So there are some traditional rules of thumb that have kind of evolved over the years. There's just not one agreed method. And there are a lot of variables that determines what is a FRAN rate, what is a royalty rate that fits the FRAN framework for a particular patent. And these variables include things like where in the value chain the basis of a royalty calculation sits. What end markets are we talking about? We're consumer, machine to machine, industrial IoT. What volumes are shipped by particular makers or implementers, and so on. And these all have an impact, which makes it very complex. And so what's really important is that you have deep experience in SEP licensing. That's the only, that assures you a more likely chance of achieving a good outcome for both the licensor and the licensees. So it's no easy task. It's a lot of work. It requires a lot of experience to get to a good result. So nonetheless, this is the framework that we all agree, all the standards contributors agree to operate under. So now we as implementers of technology into products and services have to figure out how to navigate it. So let's talk about how SEP owners get paid and how this all works in a market we're familiar with, the mobile phone market. So this is a consumer kind of use situation or market case. So, and this is an oversimplification. It's hypothetical. The numbers here aren't drawn from any fact. It's representative of what you might expect to see. So let's suppose you go out and buy a fancy phone for $1,000. So in this hypothetical example, the OEM might keep, let's say, $950 of that $1,000. And that covers all their costs of goods, their labor, their marketing and sales expenses, their distribution expenses, and hopefully, a return, a reasonable profit. The other 50 gets set aside to reserved, if you will, for covering these SEP royalties. And this is because it turns out that most SEP owners in the phone industry are paid a royalty as a percentage of that wholesale selling price of the phone itself. Now, why is that? Well, first, it's because the phone is really the first place where the cellular technology is considered really implemented, fully implemented. And then secondly, it's pretty straightforward for patent holders to know, a phone OEM's volumes and selling prices. So it's a pretty straightforward way to do the accounting, if you will. And also, there's not a huge number of phone OEMs out there, right? We know who the big ones are. There's a handful. So, and each of these OEMs has to go and figure out how to cover these patent costs, these SEP costs. So it's real work for them. But nonetheless, that this is how this plays out. Now, a phone OEM doesn't negotiate a license for every single patent in their device. They usually license patent portfolios from several licensors to kind of create, a foundation of patent coverage. But they do need to be prepared for other licensors whom they maybe don't have a previous license with. And so they have to figure out and factor all of these costs and potential future costs into their business plans. Otherwise, they're going to lose money and be spending a lot of time in negotiations and maybe litigation. So, and this can obviously harm their business. So in practice today, a phone OEM will reserve several percent, and this is a hypothetical example, but let's say it's about 5% in this example, of their phone selling price to pay these royalties. And we're not saying this is the going rate, but a particular OEM could be lower or higher, but it varies across the landscape depending on things like their the OEM's ability to cross license. Maybe they have a set of patents and they can get a reduction on the cost of their licenses from other patent holders, their volumes, basically their leverage, their power. So for example, some licensors have been public about their royalty rates, and one key owner of SEPs in the cellular landscape has publicly said for a 5G phone, they expect 3.25% of the selling price of the phone as a royalty for their SEPs. And that's just one licensor. So you can see how this can add up. There's quite a bit of money that gets set aside to pay royalties in the mobile phone industry. So just as an example. And that's a chip maker. And whether or not the phone uses their chip, they still get this royalty because it's the invention, the patent, that gets paid for it, not separately from the chipset. So let's talk a little bit about the value chain, because this is, I mentioned, where in the value chain things get assessed, the royalties get calculated. So FRAN requires parties to determine what's the proper basis on which to calculate a royalty. And there's a legal term in the FRAN framework called the smallest implementing unit. And that helps us kind of answer this question. And to vastly oversimplify, it's how you decide where the SEP technology is fully implemented. And this allows for a reasonable royalty, hopefully, to be calculated based just on the cellular technology and not on all the other stuff that might be wrapped around the cellular implementation in a given product. So now in this value chain, we could argue that the chipset is the answer, right, the basis, but it's a pretty low and incomplete level of implementation. Anybody who's worked with cellular chipsets knows that they're not fully implemented yet. There's a lot of engineering and implementation and testing that goes on. And it turns out that the SEP holders don't license, they tend not to license at the chip level because it's more lucrative, frankly, to assess the royalty at a higher level of the value chain. So in general, the cellular industry doesn't determine royalties using the chip sale. Now, if you go all the way to the top of this vertical chain, we just saw in the mobile phone market that it's the device that gets used as the basis. So, and we talked about why that is. We could debate whether the resulting royalties are reasonable, but since the phone has so many other non-SEP innovations that make that price $1,000 instead of a few hundred, is the resulting royalty fair? That's for that industry to resolve, and they've resolved it over time. It's sort of settled in. So we'll just simply say that at the device as basis in the phone market, that's how it works for phones. But what about IoT? So if we were to go all the way to the top of this chain in the IoT market or the M2M market, the problem is, look, there are literally tens of thousands of device integrators and OEMs out there and these devices are extremely variable in their final price. They cover lots of markets and use cases and price performance points. The relative value of cellular within a device varies widely across the industry. And with so many patent owners and so many implementers, it would be a nearly impossible problem to solve at any kind of scale. So in IoT, we've kind of generally decided that it's not really viable to assess royalties at the device level. At least that's our position at u-blox. So what we've said was, let's settle in the middle here. The overwhelming majority of IoT devices use a pre-designed and pre-certified cellular module. There's generally, there's relatively fewer module makers like us in the industry, maybe a dozen globally, making modules in a fairly narrow, price range compared to that device variety I talked about. So this is a much more reasonable accounting problem to solve. And importantly, the module is a relatively more complete implementation than just the chip. And so we submit at u-blox and that royalties calculated based on the selling price of the module, FRAN royalties, is the right way to go. So that's our position, and we believe that works best for all the parties. So one other point to make here is, once a royalty has been paid anywhere in the value chain, you can't demand a royalty further down the value chain. You can't be double dipping as a patent owner. Once you're paid, it's done and you're covered. No double dipping. So let's quickly wrap it up on kind of the IoT. So let's, again, a simplification, kind of a hypothetical. Let's say a meter maker, in this case, an IoT manufacturer of smart meters, say, buys a $10 module from a module vendor. Instead of the meter maker paying royalties based on kind of the price of their meter, a knowledgeable module maker seeks licenses ahead of time based on the module price, and then takes a percentage of the module selling price and sets that aside to pay the royalties. And so it looks a little similar to the phone model, but in this case, we're in that middle level of the value chain that I showed on the last slide, the module basis. And so, and I'm not trying to do a u-blox commercial. I've told you what we believe the right strategy here is, but this is how we approach it. We believe we've negotiated, therefore, proactively FRAN rates with an important set of SEP owners, and we protect against other a set of unknown holders or future holders who might come forward later for payments against their patents. And in our many years of doing this, we've kind of converged on what the safe and appropriate aggregate total royalties structure looks like to be paid under this framework. And this is a lot of work, and it adds real costs. These are real costs to us as a manufacturer of modules, but we're also confident that these costs that we take on are far lower than they would be if we left every device implementer to go out and try to figure out and negotiate those royalties with the individual patent holders. So on top of which, the comprehensive nature of our approach versus can a given device OEM really expect to get a pretty comprehensive coverage? It's very challenging. So they would still be, even if they did negotiate individual rates, still be exposed to a lot of downstream risk. So if you look at the litigation I talked about, example I showed earlier, where some module vendors and their customers were all sued by a couple of large SEP holders. Had there been a u-blox module in there, they wouldn't have been subject. They wouldn't have been named defendants there. So now those defendants have to go figure out all this mess. They have to go negotiate the rates, and they'll almost certainly end up at a higher rate than they would have gotten had they taken the route that we took. So we have years of experience doing this, and we're confident that it's the best situation for the IoT community, us as a module maker, and the patent owners, keeping this all in a reasonable space. So let's kind of wrap up this portion of the webinar and get to our guest speakers here. It's a quick summary, and then we'll bring on our guests. So like I said earlier, cellular technology has some complex rules when it comes to IPR, even in the IoT world. If you fail to kind of understand these rules and play by them a little bit, then it's a lot of risk. It's a business risk, frankly, financial and business risk. So anybody who depends on those devices or those services is at risk. And as the IoT market continues to grow bigger and bigger, cellular IoT in particular, these risks are going to become more and more likely to happen, more probable that the owners will come looking for a monetization of their inventions. And in IoT, we believe cellular modules from a provider with a comprehensive experience-based FRAN coverage at the module level can mitigate a lot of those risks and protect those IoT makers and service businesses. So we think, I guess to wrap it up here, we think it's important to consider the coverage, the IPR coverage offering and strategy when you evaluate cellular module suppliers. So I think we have another poll at this time.
Yes, let's get to our next set of polls. So the next question is, how concerned are you about standard essential patent litigation for your company? Please select one of the following: highly concerned, concerned, neutral, not very concerned, or not concerned at all. And I'll give it a few more seconds here before we can close. There's quite a few answers coming in right now. And I think we can probably shut down the poll. All right, so pretty mixed here, actually. So about 20% of you say highly concerned or concerned, then neutral at 33%, and another 20 not very concerned, and only 5% not concerned at all. Let's move on to our next question. Okay, please select one of the following to the question, has your company been subject of a SAP litigation lawsuit yet? Yes, no, or I don't know. All right, I think this is pretty straightforward answer here. So let's close the poll down. So the majority of you said no with 63%, and then about a third, I don't know, and 9% with yes. Thank you for providing feedback in the polls, and let's move on to our guest speakers.
Good afternoon to everyone. Good afternoon to everyone here in Europe, of course, and good morning to our friends across the Atlantic in the US. So my name is Tomás Jovet, and I'm the Managing Director of ESMIC. It's a pleasure to participate in this webinar, and I would like to thank everyone at u-blox for inviting ESMIC here to present its position, its perspective, and provide also one of these real-world experiences from the smart metering industry ecosystem. I would like to first quickly introduce ESMIC, the European Association representing smart energy solution providers. So we're an association based in Brussels, the European Association, and we have 19 members, and they range from SMEs to large multinational corporations. They are companies that cover the entire smart meter value chain, supporting and promoting the implementation of smart metering and enabled energy services and products. So ESMIC does not represent only smart meter vendors, but actually the whole ecosystem, including also the providers of wireless connectivity modules in this case. So the products and services that we represent here in our association, they enable customized tariffs, accurate bills. They give a precise overview of the consumption and manageable demand. And ultimately, and that's the goal, they make energy cleaner, make it more affordable and more reliable, because smart meters are not only a tool that is useful also for utilities when it comes to billing, but in the end of the day, it's also a way to address greenhouse gas emissions, energy efficiency, and in the end, put the consumer in control and put the consumer at the center of the energy system. And in this way, we see our industry very much at the forefront of this dual green and digital transition, which is very much the center of the European policy project at the moment. And it's a transformation that is not only a pillar, let's say, of Europe's strategy for global competitiveness, it's also one of the drivers for the post-COVID economic recovery. So that just a couple words to present ESMIC, and then maybe the next slide. So here you have a couple points that are really important to highlight for us. What is key is, in the end of the day, is that we need to see why it matters. So we have to discuss SEPs in the smart metering sector. Why does it matter, and what are the risks associated? So to give you here an example, first, to give you a bit of context, getting energy usage data from meters at private residences or households, and also from businesses throughout the grid and back to the utility companies is a challenge. And this was conquered decades ago by innovation in smart metering companies. And these solutions were built using both wired communication models, for example, power line communications, and wireless modes, for example, wireless mesh and cellular data networks. So cellular chipsets and module providers who participate in the development of the wireless communication standards and implement them in their products. They supply the cellular technologies to smart meter manufacturers. So this is a bit to understand also the value chain and how these things basically fit together. So what's at stake here? Why does it matter? So we have some cellular SEP holders who refuse to give license to module, to chipset, or similar connectivity component manufacturers and providers. And over the last years, smart meter manufacturers, including ESMIC's members, have been approached by SEP holders to directly take licenses to their cellular SEPs. And by choosing not to license an entire tier of the supply chain, these SEP owners are ultimately forcing the downstream innovators, including the smart meter companies, to negotiate licenses for technologies that they do not directly implement. And we have seen that also in what Craig has just outlined. So the SEP holders' refusal to license the component manufacturers is disruptive for smart energy solution companies. and the whole ecosystem, and it creates uncertainties and potential financial exposure and risks for the smart meter industry. So on the right column, you can see also, and I will introduce this now, the negative consequences where this can lead to. So the key issue here is the following. So wireless communication SAP owners refusing to license component level companies that provide the wireless connectivity modules that smart meter manufacturers buy. Therefore, smart meter manufacturers face higher costs. And this will cause, first of all, an unpredictable cost increase, which is difficult to exactly quantify, leading to business uncertainty, and will also have a negative impact on the competitiveness of the entire sector due to this price increase. And demanding that smart meter manufacturers take SAP licenses can have numerous negative consequences, and we listed here 3 or 4 that we can sum up in higher costs in what is essentially a low margin business, and draining other resources in the business. We can see that also with the different litigation and other issues going on, and then the adverse effects on incentives to now innovate. And I'm speaking here more from a European perspective, but also in that case, putting European smart meter manufacturers at a disadvantage vis-a-vis manufacturers from other geographies. And I would like to outline these 4 points in a bit more detail. So we've spoken about the higher costs in the low margin business, that ultimately then the companies may be forced to pass on to the consumers. So the continued refusal that we're seeing by some SAP owners to exhaustively license the SAPs to companies at any commercially reasonable point of the supply chain will lead to the higher prices for smart meters. And that means, again, as I said, that consumers will bear the cost of this price increase. Then the second point is the draining other resources in the businesses. So for example, as also was mentioned previously, on negotiating on IP for technologies, smart companies are not well placed to understand amidst all the legal uncertainty and lack of transparency, which could otherwise, this resource be used for innovation, innovative products, developing own innovations. And then because the cellular technologies are not implemented by the smart meter companies, they do not have the detailed technical knowledge or access to designs are needed to evaluate whether supplied cellular components infringe particular cellular SEPs. So smart meter manufacturers are unable to fairly evaluate whether cellular SEP holders are asking fair rates that reflect these important criteria, because smart meter companies do not have the complete information here. And yeah, I've already spoken about the adverse effects to innovate, or to provide incentives to innovate, especially if the downstream innovation is then in a way sort of taxed, if you want, by the SEP holders. With consequences this has, of course, on R&D investments and of component suppliers, that can lead to innovative, advanced, and also more sustainable solutions. In the end of the day, this is a technology industry which also invests a lot in R&D and innovation to develop next generation of products. And as I said, I mean, from a European perspective, it puts the industry in Europe, certainly also in other countries, at disadvantage, and that's particularly true vis-a-vis peers and jurisdictions where IP is less enforced. So maybe to sum this up, what you find on this second slide here is that, considering also that the EU has aimed to replace at least 80% of electricity meters in Europe with smart meters, wherever this is cost efficient to do so. And you might ask yourself what that means, that clear criteria in the cost benefit analysis also for utilities. This might make the case for rolling out smart meters more difficult and slow down the rollouts. And some countries in Europe are quite advanced, others less so. So indeed, this price increase might influence the national cost-benefit analysis and lead therefore to a negative result, which will not only impact the swift smart meter rollouts, but also increase the costs, not only of the meters, but then ultimately also of the whole clean energy transition, for which, as I said in my introduction presenting ESMIC, smart meters are absolutely important. So maybe here on the last slide is where we also do provide you with some proposals on how we would like to address these concerns and avoid endangering the smart meter rollout and ultimately the clean energy transition. So in a nutshell, what we propose is that SEPs in the smart metering sector should be licensed on a fair, reasonable and non-discriminatory basis. So FRAN, Craig has introduced the concept of FRAN. But concretely, what does that mean here? I think there's a commitment that is intended to, and 3 key points is to ensure that patent owners receive reasonable compensation for their patent and innovations as applied to smart meters, to prevent patent owners from receiving remuneration for innovation that is unrelated to their own innovative efforts, and ultimately stop patent owners from refusing to license to any company willing to negotiate and sign a FRAN license. Moreover, SEP holders should not be able to refuse a FRAN license to patent implementers simply because of their position in the product supply chain. I mean, this, in our view, such a denial would be a violation of the SEP holders pledge, specifically the non-discriminatory principle of the FRAN obligation. So royalties, of course, can be paid at any level of the value chain, in any level of the value chain where the SEPs are actually implemented. So this could be at the chip, component, intermediary device, or end product level. But FRAN-based license royalties should only be set based upon the value of the component implementing the SEPs and should not include the value of other components or technologies commonly found in the intermediary or end product, many of which have nothing to do with wireless connectivity. So while it's important to assure a patent holder receives remuneration for the sunk costs and research that led also to the innovation captured in the SEPs, not a reasonable profit. And this is equally important that a product manufacturer does not pay a royalty based on innovation and implementation that was not contributed by the patent owner. So thank you very much, and I will stop here.
Thank you, Thomas. Thank you, Craig, for your brilliant talks. So my name is Sebastian Heidebrim from SICK Sensor Intelligence. So who is SICK Sensor Intelligence? We are a company, we are hopefully having our anniversary, 75th anniversary this year. And we are about 10,000 employees all over the world. We are one of the leading supplier of industrial sensors and sensor intelligence, which means software and algorithms behind the sensor. And I would like to give you an insight practically where I see the major markets for wireless communication and for cellular communication within our product portfolio. So we are one of the market leaders for LiDAR sensors and light grids safety systems, which just prove anti-collision, which means collision between two vehicles and between vehicles and, more important, human beings. And so whatever you find on the market on automated guided vehicles, which is just the autonomously driving vehicle, you will most probably find 2 or more 6 sensors, LiDAR sensors in the front and in the rear, going backwards and forwards. And we are speaking about here about the forklifts, movers, whatever, and we're speaking about the small ones are we're speaking about carriers and not vehicles, because they are just smaller and have less impact on harming people. And so this here we have a major value of wireless communication, because a cable for a mobile machine is just not thinkable. It's not suitable. So we need some wireless communication, but within the factory, we already have technologies which are probably more than 20 years old. I'm speaking of Wi-Fi, even though they are most probably using more modern versions of Wi-Fi. But this is the competing technology to cellular communication. But looking to the future, where vehicles are going outside the factory, and where vehicles from outside the factory, electrical vehicles, are going into the factory, this is just is blurring then this edge of the factory, that we have an inside of the factory and an outdoor application. So this is changing, and we're speaking here about machines which are much more expensive than a fancy smartphone. So applying the same rules for granting licenses is not suitable here, because the major value of such a machine, of such a mover, of such a vehicle is not wireless communication, and even more the requirement of such communication is not that real-time specific. That means we need some dispatcher who tells the mover or the vehicle where to go and when, and then the vehicle will act on its own, more or less autonomously. A second, even more expensive application we see perhaps on the next slide. Here we see an overview of different industries where we see mobile machines, what we summarize as mobile machines, and we are speaking here about prices several $100,000s for one machine. So what we see is the industry of construction machines, mining machines, so the big trucks, excavators, and then in agricultural industry, forestry machines, this agricultural machines. We normally separate here between a main machine, which is just the power supplier, just moving, but the real value is just behind or is attached to the main machine, which is called the implement. And the implement mostly has the knowledge of what to do, when to stop, when to go faster, when to slow down, and so on. And you can probably imagine that if you calculate a price for a wireless communication module by perhaps taking 1% of the total machine or the total implement, which is again several $100,000, then it would be cheaper to call a servant to deliver the message by horse or by helicopter or something like that. So it's not suitable to apply the same rules for granting licenses here as for a smartphone, which is more or less a communication device. Another aspect is, another industry is, we call it municipal and special vehicles. So we're speaking about fire department vehicles, about the movers of waste, and we have lots of vehicles on airports, on the ground services. And last but not least, this is, I think, the most important industry for us is the logistic yard, which is perhaps an extension of the intralogistic we have within the factory. And here is the boundaries are reached of Wi-Fi. So on the logistic yard, where we have trailers, you have goods placed there. It's not only vehicles and trailers, it's also goods you park on the outside where you want to know where they are and so on. So asset tracking is also an issue here where we need low-cost devices for tracking goods. And this is also an interesting future business for wireless communication here, because we have wide areas to cover. Yeah, next slide, please. To summarize, what I see is for a technology decision, as I told you, you could rather when someone delivering the message as a human being on a horse or something like that. So at the beginning, you are calculating what can you demand for a certain added value, for a certain value for the customer. And then you do your technology decision, whether to choose a human being or choose perhaps a really old-fashioned technology or use a state-of-the-art technology. And then you calculate the price you can afford for this solution. And you are well advised if this price fits what you will actually pay. So later demands, and I see here a major risk for state-of-the-art technologies like cellular communication and especially 5G, is that we fear, it's just a feeling, that we can't calculate the real price of licenses for the technology being used. So later demands are just not fair. You are in a bad situation if someone comes after you have sold hundreds or thousands of devices, depending on your mass and on the single price, and saying, okay, you have already sold 500 devices and I need 5%, 1%, whatever. You haven't calculated, it's not calculatable if you don't know the price, and you have a bad situation in negotiating here. So this is a really uncomfortable situation, which I believe that machine builders will try to avoid, and this will perhaps hinder will reduce the success of such new technologies. And remember, so as my last sentence, that the value of wireless communication is usually rather small compared to the price of the machine in total, because the machine has much power, it has very complicated algorithms, very complicated technologies and whatever, and wireless communication is just an add-on to have a remote access, to have perhaps more intelligent supplied by any data center or whatever, but it's not the major value of the machine. Thank you very much.
Okay, thank you to our guest speakers. So we will just summarize a few points to close things out.
So Kent, I believe, will kind of discuss here now a few of the questions we think you should ask as an innovator, user of cellular technology. So Kent, you want to take this?
Yeah, Sebastian made a very good point that when you don't even know what the aggregate royalty is that you would pay for a cellular communication, it makes it extremely hard as a business, actually impossible, to go ahead and realize what the actual cost would be of that future machine that you're trying to design and build, much less be able to offset alternatives to actually implementing that technology. And that's a key point here, because it's not just the royalty rate charged by one patent implementer, it has to do with the cumulative rate or the aggregate rate, and that's something that's still not known. Now, one of the reasons for doing that end product calculations, of course, are higher returns on what you're going to get for your patents. One of the issues with that, of course, is how is that related to the actual value of the technology? You know, if you're looking early on at, say, something like 3G, where you had 10 people inventing into that technology and the standard was at risk of failure, the risk was very high, and you'd expect a higher return for those companies that stayed the road. I know that personally, having come from Qualcomm during that time period, you know, how this worked. On the implementer side, that's great, but the aggregate royalty or the value of that technology didn't change. It's just that each individual inventor or company at that point would receive a higher return. So the questions that you need to really focus on and like that is trying to find out really from your module manufacturer, how can these problems and these risks be eliminated for you? Things such as the royalty that you would pay, can that be incorporated into the module price that I'm going to be charged? And you can look at it this way. You may pay a few pennies more to get that IP coverage on the module you select and implement into your device. But the value of what you're putting into it, if you were sued individually, literally runs in the tens of millions of dollars. And with the increased risk of litigation, the business disruption that goes with it, it's a serious concern, which in the past we didn't have to worry about as implementers. But it is something that you do need to worry about, and I'm dealing with multiple different companies that are now in that position of, as Sebastian said, being sued after the fact. And they just incorporated some IP value, but certainly not enough to go ahead and cover what the ask is. So the fine print of the indemnification clause, this is usually and traditionally has been a get out of jail free card that a module implement or module provider would go ahead and say, well, we'll just indemnify you against any lawsuit that comes. That may have worked traditionally in the past when the majority of patent holders used defensive licensing. In other words, they didn't sue. But the size of these recoveries can be in the literally tens or hundreds of millions of dollars. So for a small module manufacturer to then be able to step up with the growing risk of litigation, indemnify becomes somewhat unreal. So you need to look closely at the indemnification clause. Many require things such as a final verdict. Well, that's legalese, which says that basically the judge has to make a final decision, and then you'll get your indemnification. But up front, you're still going to have to pay the cost of the lawyers and the litigation to fight it. And that literally can run $5 to $7 million in the US, plus your business disruption, and you can't discount that. You need your internal people who are usually doing R&D. They get pulled off to start finding documents during discovery. Many things are required in the litigation distract you from your business goal, much as any other type of business risk that might come up. And that is just something that for many companies, especially according to our poll, small companies with less than 100 employees, that makes you just less competitive. And it's not a risk you need to deal with if you let your module supplier deal with it for you and bring that expertise to the table. Do we offer support in case of a patent infringement lawsuit? Yes, if you're one of our customers, we do step in and help, because who understands the technology better than the module manufacturer who actually implements the cellular connectivity into the module. We don't let our customers just sit there and flounder and try to figure it out, because many times they will have a single attorney in-house and they need to reach outside. Yet, as our poll also showed, many have no SEP background to actually select good counsel to represent them. So we're more than happy to step in, use a comprehensive IP approach that we have at u-blox, and then share not only our technical expertise in helping guide whether or not there is actually a standards essential patent involved, whether or not there's actually infringement, but then also to help guide through the process of how all of this works. As Craig said, this is a substantial overhead, and it's one that u-blox several years ago decided to carry for the benefit of its customers, because much to the credit of the executives of u-blox, they saw this coming and stepped up to try to defend the customers, and that's really what we do. Sabrina, I think we're back to the poll.
Let's get to our last set of polls here. So are you planning to start a cellular-based design within the next 3 months? Please select either yes or no. And while those answers are coming in, to be mindful of time, I don't think we'll have enough time to do a live Q&A here today. However, feel free to use the questions panel, and we will get back to you after the webinar on those questions. All right, so results, no, 69% and 31% with yes. And let's move on to our last poll question for the day. What is your current yearly consumption of cellular modules? Please select either less than 1K to 20K or over 20K. All right, let's close out this poll as well. All right, so almost half of you said less than 1K, about a third said 1 to 20K, and just about 20% said over 20K. So to move on and to summarize just a couple key conclusions from the webinar.
Right, we're at the end of time here. So just a quick wrap up. Thank you for staying. A couple of key points. So again, cellular IPR issues are increasingly adding risk to the IoT device ecosystem and business owners. A supplier's FRAN-based SEP coverage should be part of your evaluation criteria, not just the product performance, attributes, features, and price. Those don't matter a whole lot if you can't deploy, if you're shut down, or if you have to pay, back-breaking royalties and legal fees later on down the road. Our colleagues here, our friends from ESMIG, reminded us that, this is an important industry. Smart energy is an important industry, and they're seeing real risk and damage from folks who just don't want to operate by these pledges they made in the 3GPP space. It's stifling innovation and hurting the mission of smart energy. CKG similarly reminded us that knowing the cost up front is the only way to operate a reasonable business, and minimizing that risk. And without this, innovation can be stifled. And then finally, as we've said, we have experience here in negotiating SEP coverage, FRAN-based at the module level. We think it's the right way to operate in this IoT industry, and it's the best way to reduce risk for our customers, as well as enable the inventors to get paid a fair return on their R&D investment. So with that, we're out of time. I don't think we have time for live Q&A, as Sabrina mentioned, but please post them in this sideboard here, and we'll be happy to try to get back with answers.
Yes, thank you all for joining today. And I also would like to point you to the handouts, which we are making available as part of the webinar interface. So you can get access to this presentation through the handouts. There's also a blog post that we've made available as a PDF, but you can also find it on our website under the blog, which is 3 IPR questions to ask your cellular module supplier. And then as part of the handouts, also there is a position paper available from ESMIG on Sap IPR. With that, I think we can close it out. Thank you all for joining today, and have a good rest of your day or evening.
Thank you.
Thanks, everyone.